Okay, a lot of you have seen this diagram before. This is where the story of differentiation starts. On this page here, the idea here is to talk about the gradient of a curve at a point. So if I may draw for you the same diagram, but over here, the aim in this discussion here is you are interested to find the gradient of a curve, say at a point here, where this A.
Wait, some people don't have their assignment.
We settle it later. What do we mean by the gradient of a curve at a point, say P? It means to find the gradient of the tangent line at the point P. This is what it means, right? And the story goes this way, you know, to find the gradient of the curve at the point P, we want to look at a nearby point Q. While P has a coordinates A and FA, YFA, because this is the graph of y equals to fx. The point Q, right? The point Q is given an x-coordinates of A plus h. So the point Q has a coordinates of A plus h, f of A plus h. And before I forget, I want to shut down this. Yeah. Oh, thank you. Right. So now, in order to find the gradient of the red line, we actually first and foremost draw the green line. Do you see the green line on the diagram? You know why? Because I have not drawn it, I know. Right. So if I ask you, what is the gradient of the green line? The gradient of green line would be f of A plus h minus f of A over h. What is the gradient of the red line? The gradient of red line is denoted the gradient, right? This gradient is denoted as f prime A. Certainly, right, when you look at the red line and the green line, you can see very clearly that the gradient are not the same. Right, not the same, obviously, right? The green line has a gradient that is distinctly different from the red line. However, if we were to close the gap, what do you mean by close the gap? If we let h to be small, how small? As small as you can imagine. When the gap h is very small, what will happen is this gradient of the second line will approach the gradient of the intended line. Agree? Symbolically, this whole thing is written formally as in the limit when h goes towards 0 of f of A plus h minus f of A over h. Symbolically, it is written as like that. And there we are. The gradient of a curve at a point is now given by this definition. We can also rewrite this expression as like that, You can rewrite this expression as like that. Why is that so? Because if you were to now do this, if you were to see the A plus h, right? If you see the A plus h as your x, then x minus a is indeed h. If your x is a plus h, when h tends towards 0, x tends towards a. No? So synonymously, you want to know that there is another equivalent statement for the same thing.
That's the definition that we were taught last year.
This one is it?
The one in the green box.
Green box, this last year.
Yeah,
This was last year, right?
Yeah, so we were taught that last year, but we weren't given any like further explanation.
Oh, okay. These two are synonymous. They can be used interchangeably. And that brings us to our notes here. This whole page is to tell you about the differentiation story. You want to be able to actually tell this same story back home. You can catch hold of your little brother and sister, or even your grandparents though. Jethro, I can hear you. You sit them down, and then you want to be able to tell them this differentiation story. That is actually a true mark of your understanding of differentiation. And you want to be able to do it without anything, like what I did earlier on. What I did was I started off blank, and then I started to tell you the story about differentiation and how I have taken the limits to end up with these two statements. And as you already know, this branch of math was created by who? There were two creators. Again, definitely not you. One of them was our famous guy, the Isaac Newton, and the another person is actually from Germany. It's a German guy. Yeah, left knee, right? Right. His name is Lei, and I think it's like that. I hope. Okay. There's a B somewhere, right? Okay, yeah, very erase. Okay. Anyway, you can Google for it. Yeah.
No, it's Leibniz.
Okay, Leibniz, is it? Okay. Now that you have understood the statement, or this statement, you now want to look at f prime a again. This symbol, right, f prime a, on one hand, it represents gradient. On the other hand, this f prime a also represents instantaneous rate of change. If you were to look into the history of the creation of this branch of math, you realize that Isaac Newton saw it more from this perspective, instantaneous rate of change, because Isaac Newton was a physicist. He dealt more with all those moving objects. The German guy actually saw it more from the gradient of a curve. And apparently, right, this German guy, by training, he wasn't a mathematician. I told before, right? Did I tell you? Yeah. He was actually a lawyer, right? He was actually a lawyer before. No, not because he got sick of math or got sick of law. No, it's not. It was because no reason. Okay, I shall keep in suspense. You should read up about him, so that I won't spoil the story. Okay. You want to also get accustomed to the symbols. I am almost sure that you have seen this symbol before. You have seen this before. I am not so sure.
Is that for domain?
Bullshit, it's not. Okay, say after me, everybody. It's called the D operator.
What?
Who uses this notation?
Is it the D operator?
No. It's called D operator. D operator. Okay, who uses the symbol? The engineers. You won't see the symbol at all in our notes again. You won't. Okay, let's do our first example. In example 1, you are given a statement on f prime 20. what does f prime 20 measure? Bearing in mind that this function f is a measure of the water depth x minutes after. Let's hear from Kurtish. What do you think is f prime 20? Oh, sorry, I was just dreaming. Okay. Okay, Jethro lah. Okay, Jethro. He got bunk idea. He got bunk. Okay, there's a name list here. Thank you for that. Okay, Jethro. What is f prime 20 to you? Is it the rate at which the depth is increasing? You say yes, right? Yeah, it's true. How about 2, Jethro? Do you think it's true? Yeah, you're right, it's not true. How about third one? Is it true? He's not looking anyway. He's not looking. And Jethro says it's true for the third option also. So for the reason, he therefore has picked E as the answer. And he's right! Yay. Remember, there are two meanings to f prime. Instantaneous and the gradient function. Okay. This question is nice, no? This question is nice. Let's see how Gary is going to do it, you know. Gregory, sorry. I missed Greg. Okay, let's call him Greg. Shh. Silent. How would you do it? Okay, it's too faint. So what he says is, he drew a line. This line is kind of faint, you know, but you can see he drew a line at a point x equals 2, right? Greg, you're saying this, right? Do you see this? Yeah, right. And then he says, after drawing the line, he wants to actually guesstimate the gradient by taking the rise over the run, the good old days. And you know very well that this method is absolutely accurate, you know. To start with, trying to draw the curve freehand is almost impossible. Even you can draw a best curve using a computer-aided thing. To draw a tangent line is not easy, you know. All taken together, right? You find that this method is highly inaccurate. But nevertheless, is there someone who can offer me an answer to this?
You can use the local linear.
Yeah, some people cheated. They say, Mr. Lim, this function is actually like that. Someone say they can actually calculate, they can write down the equation and then they can use differentiation. If you do it that way, of course, you are second guessing the equation of function. I think you're right. This time around, this guess is correct. But in more difficult curves, I guess you just have to hope for the best, right? And you really have to do it this way, you know. Draw the tangent line and do your guesstimation, and your guesstimation would yield the answer of what? 4. Right, the gradient ought to be roughly 4. You're supposed to do that, but seriously, it's very hard, you know. It's very, very hard.
Wait, then why do you say that it was a nice question?
Because you can't get answer. By freehand, you can't get answer.
Oh.
Because everybody get different answers and all acceptable. Yeah. Okay. For the next part of it, there's a paragraph here to try to explain to you what is going on. But let me bring you into this example to explain to you what is going on. Okay, what's going on here is sometimes in the exam question, right, they give you a table of values such as this, and they say based on the table of values, you want to guesstimate the gradient at this point. Now, you may differ in opinions. However, the syllabus requires you to do like this, no? Okay, go listen very carefully, no? Shh. This one, I may get objections from the floor, but I'm going to tell you how this will be done, okay? For example, to find the gradient at 1.94, to guesstimate this gradient at 1.94, the guideline is like this, no? The guideline is take two nearby points equally on the left and on the right, and use these two nearby points to guesstimate. How? By finding the gradient of the 2 points on the left and on the right of the point in question. Simit. Huh? Yeah, I'm going to tell you. Akan datang. Coming. Okay, and then you get the answer, no? So this is what it is given to you as a guide how you ought to guesstimate the gradient of a point such as 1.94. Yeah, what do you see? Right, okay. Okay, you're supposed to guesstimate the gradient this way, no? And then, of course, you can use your calculator to get the answer. And now to answer Aditi's question, right? F prime of 1.92. For the endpoints like 1.92, right, the guide says use this point in question and the next available point. So therefore, the guide says to use 1.94 and 1.92 itself. Now, of course, some people from the class will say, Mr. Lima, this method, right, need not use the best estimate, and I second the motion, you know. Yeah, it's true. This way of getting the approximate gradient doesn't really have any science behind it, you know. It's just a rule of thumb. It might not get you a good estimate actually. In fact, it can be worse. But the best we can do, okay, this is the best we can do. Right? If you try to draw a graph like this, right? Draw a graph like this. You intend to get the gradient at this point. But if you use two nearby points, that are like this and like this, right? Then the gradient that you get can be entirely wrong, you know. Can you imagine the red line that I draw has a totally different gradient from the intended one, you know? Ashad, you agree or not? Just say yes. Yes. Okay, you're right. Okay, so you have to actually do the calculation using a calculator. In the interest of time, I'm going to show you this fella. Show you the values here so that you can jot down. Huh? Okay.
I do not wish to keep moving.
How do you see?
You went boarding yesterday? Did you come back boarding yesterday?
Yeah.
You came back to boarding?
Yeah.
Why would you bother? Why don't you just come straight from home?
Huh?
Why don't you just come to school in the morning? This morning, just sleep at home. No.
Boarding is compulsory for year 5 unless you have
To check in before time, is it? Before the day?
Yeah,
the day?
so the day before you have to check in before
okay.
You are required to move it.
It's compulsory for all year 5 unless you have like a special like medical,
Right.
medical whatever.
Right.
It's too much fun to like write in.
Maya, you have something to tell me? What is it?
Maya.
Is it Maya? Is your name Maya?
Chipmaya.
Chimaya, right? Okay. Can I call you Maya or you prefer Chimaya? Chin. Okay. So this approximation thing, I want to reinforce this thing. No, it is not 100% accurate or good. It's just a guide, and you just have to follow this. No, you cannot say, Mr. Lim, I disagree with this, and therefore I want to estimate the gradient at 1.94 or 96 my way. You're just asking for it. If this thing comes on the exam, you're just asking for it if you do it otherwise. Okay. Can you see?
Yeah.
Okay. I actually don't need glasses. Who in this class don't wear glasses at all? Don't need spectacles at all? Nice. You're the minority who can become the Air Force pilot, Yeah. The minority. Jingwei writes faster than you.
Okay, carry.
Okay. Okay, let's press on. Okay. Class. Let's find the gradient of this function at 2 using the two methods. What are the two methods now? Remember, f prime a on the one hand can be written as limit h goes towards 0 of f of a plus h minus fa over h.
Okay.
On the other hand, you can also do the same thing. F prime a is equals to the limit x tends towards a So now on the left side, let's do the red color. On the blue side, we do the method 2 again. On the right side, we do the blue color. Can you try right now? So to find f prime of 2, by definition, you become limit h a 2 plus h bar 3 h. Daewon, is it Daewon? You got something to share? Huh? Jingwei was so ticklish. Check my calculation, I might be wrong. After expanding and tidying up, I expanded the 2 plus h power 3. You have to expand the numerator, no? Faithfully, expand this thing. Power 3 is actually what? A cubed plus 3a squared b plus 3ab squared plus b cubed. It's correct.
Yeah.
Okay, thank you. And then in the limit, when h goes with 0, this gives you 12.
What is the case of the
Which one?
The limit, the limit.
Why did you?
Let's go here.
It is indeed h. Okay, let me rewrite again. Hey, thanks for finding out.
1 year is oh, so then you can cancel out the huge. Because it's a limit.
In between the gaps, in between the gaps.
Oh, okay.
Yeah, I've jumped. I've deliberately jumped.
Okay.
If you get it correctly, that's great. If you make careless mistake, then you had it up. I prefer to expand it nicely in exam. Okay. Now on the right hand side, let's do it in blue. Maybe for this class, starting from chapter 3, shall we all do digital or send the PDF notes?
Can you send to the school one?
Yeah. Who wants? Okay, maybe I drop it onto the class WhatsApp and see how people will take it up.
But not the very loud though. There was no saying yes in there.
Your era, right, is the digital world. Okay, I hit the wrong thing. Yeah, drizzling.
That's quite easy. Oh, this weather is so good. Yeah.
This is good for sleeping. When you
Wow.
read that for me,
It's like you sleep. 我有 sleep.
他的我朋友的那个分手也。
Hey, I made a mistake, no? I want to change. It's 42. I say.
At least you can erase.
Yeah, you see, it's so convenient, right? Can erase. Two.
Man.
Parroting. What is it? Oh yeah. You see, digital world is very good, right? I can straight erase. Not fast about it.
Skill issue removal. Skill issue removal.
Use correction.
It is so hard to cancel the bad. This is one
Maybe in 20 years later, maybe can be digital for exam.
If it's digital for exam, they better give us like a proper device or else everybody is going to type.
Actually, if you can use typing for essays, it's very good, Yeah.
Why are we allowed to use?
Because I'm scared of cheating.
Right, we can use like local area network.
Maybe you're right.
Not there.
Okay, now to find a general formula for f prime x. You're done with this page? This part here? Yes, Okay, let's find f prime x in general. This becomes
I think which one? I was reading. I was.
and this gives you limit x plus h cubed minus x cubed. And then
Oh, you later you need to go and because I did like take note of the numbers.
If you expand and tidy up, right? In the end, you will get this line.
I'll send that.
So that confirms that if your function fx, right, your function fx is x cubed, You want to realize that the f prime x. Yes. I mean mistakes.
The second term should be 3xh, I think. Is it? 3xh.
3xh. Oh, I made mistake. 3. Okay, let me rewind. This is 3x squared.
3x squared plus 3xh.
Don't give me any like wrong idea.
No, I know.
Let me see. 3xh squared, right? 3xh. You're right. 3xh. Sorry, I made mistake here.
I don't know it's me. What's it?
Right, thank you. Yeah, it's 3xh. And then plus.
What? Why can't we just do divide?
No. This process of differentiation, right? Actually the basic working is actually here. This one is by memorizing of formulae. You memorize it, but the internal working is actually given now here. Right. So last time, right? If you want to do differentiation by using those formulae that you know of, you're not doing by first principles. What is it?
Can we still stick to the normal method even though now I don't think that's done?
Yeah. You're not expected to be always doing the limit thing when you can just differentiate sine x immediately or cos x immediately. However, let me ask you this question, class. What is the differentiation of if you can prove this statement from first principles, you're not bad, really. If you can prove that differentiating e power x is e power x, right? You're really not bad, You agree or not?
Yes. Oh, okay.
Jin Shok, is it? Jin Shok, you agree or not?
Whatever you say, I agree.
Yeah, thank you for that agreement. So you want to try this question, Tingwei, you're feeling too sleepy and too, you can try this now. This is quite nice, really. For those who don't feel challenged, with all those x cubed and x squared from first principles, you want to try this one. It's quite interesting. Okay, let's do the next example. Example 5.
Those minutes.
How do you find f prime 0? Right, by definition, the f prime 0 is to be calculated like this. Then this becomes limit x goes with 0 of okay. Many people are very hasty to say this is equal to 0, but actually I prefer that you do a bit more working to show that you have to do the left and right limits,
Oh, then never mind, it's okay.
You should really do the left, because the modulus function is defined differently on the left and on the right of 0, is it? Yo. Clever idea. There's a clever idea from the back that says, why don't I do it like this? Okay, let me just do it for 0 plus it's the same thing, no? Someone behind says, if you're asked to do a question that's like this, I don't need to do left and right limits because I can simply take out this thingy as x squared modulus x. You know what I mean? And then the suggestion given here is this one will be either +1 or -1, but it doesn't matter because this one will always be halfway. I was halfway. Okay, we did this. So let me rewrite this thing again as f prime 0 is equals to limit x goes with 0 or f of x minus f0 over x minus 0, and this gives you limit okay, now I take the suggestion given to me. Got
This is a horror story.
right.
I saw this. This kind of system.
And this gives you 0. You can't cancel, no? It's either 1 or -1. Ah! But after cancellation, right? After cancellation, we have a problem, you know. I think better not. Maybe from here left and right lah. Okay, I think better just put 0. Okay, let's put 0. Okay, better put 0 for a moment. I think let.
Can you draw?
Okay, in the long and short, I think better do the left and right limits to be on the safe side.
Can you draw a graph to prove continuous?
Cannot. Okay, we take it offline. Maybe yes. Okay.
Like Ian is asking whether you can take out x squared.
This taking out x squared is okay.
But you cannot cancel.
I'm just skeptical about cancelling, you know. I'm just skeptical about cancelling. Let me see. Can I cancel?
Just wait to do cancel.
Let me see. So the suggestion here is, let me see. Can we cancel?
Yes, cancel one time.
Okay, let's cancel one time. If we cancel one time, okay, I think maybe we can.
When you still have to prove on left and right, because you don't know like x whether it's
it'd be a minus x squared or positive x squared. Yeah, you're right. But okay, actually it's okay lah. I think that's okay.
Let's go.
However, it's good that you always follow the rule of thumb, you know, that you want to bring the two from here. I prefer to bring the left and right limits to be on the to be very sure.
It's not that bad. This one is not that bad. A lot worse.
To be very clear. Okay, to be very clear, actually I prefer this working now. Okay? I leave it to you. Okay, I leave it to you. And this equals to eventually is 0. Okay? Let's try the next question. In the next question, you're asked to prove that that g prime at -2 does not exist. So first and foremost, let's catch this graph. In front here, I was asked, can we just see from the graph and say that therefore it is not differentiable? And the answer is no. You know, the graph gives you a guide, but you still want to do it by calculation that g prime of 2 by definition is -2, not 2, -2. So this gives you limit x goes towards minus 2, then you got modulus of x plus 2 over x plus 2. And then you know very well that for this kind of question, again, you got to do the left and the right limit. If you do the left, minus 2 minus of x plus 2 over x plus 2, because you're doing the left limit, right? When you remove the modulus sign, this becomes a minus, and this gives you a minus 1. And then when you do the right limit, oops. Okay, the bell has something. I'm getting okay. What do you have after my lesson?
None.
Okay, this is a very important thing. Cannot be late. Okay, and therefore G prime does not exist. Okay. Go for your lunch quickly before the crowd builds up. Class is dismissed. Goodbye, class. Once again, goodbye, class.